This video provides an overview of an analysis conducted by the National Institute of Standards and Technology, or NIST, to provide insight into the dynamics of a fire that resulted in a line-of-duty death. On November 2, 2012, a fire in a 2 1/2-story residential structure claimed the life of a captain of the Chicago Fire Department. NIST examined the fire dynamics of this incident at the request of NIOSH and the Chicago Fire Department. At 5:16 in the afternoon, dispatch called a still alarm for smoke in the area. Battalion 19 arrived on scene within a minute of dispatch. He reported a working fire with heavy smoke showing from the rear in front of the structure's attic. Battalion 19 made entry through the front door and took the stairwell to survey the interior of the second floor. He observed a light haze of smoke throughout the second floor and a glow around the rear door to the enclosed porch. Battalion 19 returned to the front door and met the Engine 123 captain and firefighter. Battalion 19 made entry to the first floor apartment and worked his way to the rear of the structure. From the inside, he opened the door that led to the rear foyer on the back side of the house and noticed heavy fire in the enclosed porch and rear stairwell area. Within 5 minutes of the dispatch, the Engine 123 captain and firefighter were on the second floor, where they advanced a charged hose line toward the rear door of the apartment. Another firefighter went to the rear of the structure to check doors. He first went to the basement door, which he was unable to force open. Then he made entry to the enclosed porch at the first floor level. He stated that he noticed fire light up in the stairwell. He kicked in the locked door that connected the porch to the rear foyer. He saw no fire on the first floor and backed out. Approximately 6 minutes after arrival on scene, Battalion 19 radioed the Engine 123 captain that there was heavy fire in the enclosed porch and attic area, and that Engine 49 was going to put water on the fire around the rear attic window. There was no acknowledgement from the captain. The Engine 123 firefighter, paramedic, and 4 other firefighters were near the kitchen on the second floor when they heard a loud commotion. The Engine 123 firefighter, paramedic heard the captain yell, "Get out of here!" The Engine 123 firefighter, paramedic yelled Mayday as he tried to get the captain and the Engine 123 firefighter untangled. The other 4 firefighters heard the verbal Mayday, and a Mayday was transmitted over the radio. The firefighters grabbed the Engine 123 captain and got him down the stairs. CPR was successfully performed on the Engine 123 captain. Unfortunately, he succumbed from his injuries shortly after arriving at the hospital. NIST's Fire Dynamics Simulator, or FDS, was used to provide insight into the dynamics of this structure fire. The inputs and details for the FDS simulations are documented in the NIST Technical Note 1838. The fire started in the attic and spread down through an opening in the enclosed porch on the rear of the structure. The heated gases of the fire increased the pressure in the attic and porch area. The increased pressure forced the smoke and flames out of the gable ends and eaves of the attic, as well as the holes burned through the walls of the enclosed porch. The fire in the attic and rear porch areas was also ventilation limited, or fuel rich. The spread of fire and hot gases into the second floor of the structure was initially stopped by a closed, steel-faced wood frame door. After exposure to elevated temperatures and pressure from the fire in the porch area, the wood frame of the door decomposed and the upper portion of the door collapsed, allowing the higher pressure hot gases to flow into the lower pressure hallway where the captain was located. The door failure resulted in the establishment of a flow path between the higher pressure and higher temperature conditions in the enclosed porch and the lower pressure and lower temperature conditions in the hallway and kitchen areas of the second floor. This video shows the second floor plan view. The temperature estimates are shown at 6 feet above the floor. The temperature of the gases that flowed into the hallway at this height exceeded 500 degrees Fahrenheit within seconds of the door failing. The model results presented so far only considered the flow into the hall with the top half of the door open. What if the door folded over and then fell open? The images show the comparison of the flow results with the half-open door and the full open door. There have been many previous fire incidents in which changes in the flow paths have had an adverse impact on firefighter and occupant safety. Fires with rapidly developing or changing flow paths are a significant hazard to firefighters. The development of a flow path could be caused by the failure of a component of a structure, such as a door, window, or portion of a ceiling, wall, or floor. Environmental conditions, such as wind, can generate hazardous thermal conditions within a flow path. Uncoordinated ventilation or uncontrolled doors can also be the cause of increased thermal hazards within a flow path. In this fire incident, the thermal degradation and failure of the rear porch door resulted in a rapid increase in temperature and fire gases in the hallway, conditions that changed from tenable to untenable within seconds. Prediction of the failure mode and failure time of a building component is not a reasonable expectation given the large number of unknowns that the firefighters face on the fire ground. Research has been conducted by NIST and UL with fire departments across the country on exterior fire attack. The studies have shown that the application of water from the exterior into the fire area of a structure prior to the start of interior operations can significantly improve the safety of firefighters by reducing the thermal hazard from the fire and reducing the potential for developing high-pressure, high-velocity, hot gas flows within the structure. The exterior attack should be made with a straight stream or solid stream. When sizing up a structure fire, choose your tactics with potential flow paths in mind. Recall that in a flow path, heat moves from a region of high pressure to a region of low pressure. Firefighters located in the flow path downstream of the fire can be exposed to deadly levels of heat. Therefore, it is critical that crews coordinate ventilation and suppression tactics. For more information on this incident, see NIOSH Report 2012-28 and NIST Technical Note 1838. These reports and other information on flow paths and fire dynamics can be found at the NIST Firefighting Technology website. For updates, follow NIST on Twitter.